Good evening, guys. My topic tonight is definite integrals. The last time around, we finished already evaluation of indefinite integrals. So tonight, I will be discussing definite integrals. Okay, let's proceed. Definite integral. This is lesson number 43 under integral calculus on my channel. This is the second mathematics on my channel. The first one was differential calculus. It was a complete course. My next topic on mathematics under my channel is integral calculus, and I am now on lesson number 43. We are almost on the application problems of integral calculus. It's becoming interesting, guys. Okay, I will bring out the form of a definite integral. What's the difference between definite and indefinite integral? Indefinite integral, after the integration, we got a plus c in our answer. Okay. For definite integral, we do not place a plus c on our final answer. The reason why? It got a lower limit and upper limit. So if you see an integral sign with the value a here and b here, that is supposed to be definite integral. Okay, I will read this. The integral with the limit from a, lower limit a, upper limit b, of function of x dx equal to, if we try to integrate this, there will be a function, right? So the function will be designated capital letter F as a function of x, open bracket, close bracket, with the limit a and b. So actually we don't have a plus c over here, because if there's a plus c over here, that's indefinite integral. So for definite integral, it should have a limit. It should have a lower limit and upper limit. So there's no plus c. That's the difference between definite and indefinite integral. Okay, I will try to bring out the legend. Capital letter F as a function of x is the integral of small letter f function of x dx. It's the solution when we integrate function of x dx. That's the meaning of capital letter F as a function of x. Capital letter F as a function of a, the value of the integral at the value x equal to a. Function of b, the value of the integral at x is equal to b. Meaning, we are given f of x, so if we try to substitute the value of x equal to a, that's the meaning of f of a. F of b will be the value of the integral at x is equal to b. Just go back to this, substitute the value of x equal to b, that will be capital letter F as a function of b. Meaning the value of f of x when we substitute the upper limit. This is the value when we substitute the lower limit. Okay? Where a is equal to the lower limit and b is equal to the upper limit. A is the lower limit, b is the upper limit. Oh, that's just a definite integral. If you try to read books on calculus, okay, and if you don't simplify what you will be reading, you will get lost. So I will make the explanation of this as simple as it can be, okay? So finally, I will bring out the integral with the limit of from a to b of f of x dx is equal to f of x, capital letter f of x, with the limit from a to b. We got the lower limit, we got the upper limit, so we got the function here. Take this value, place it here, that will be f of b. Okay. Take this value x equal to a, place it here, that will be minus f of a. So the significance of this Okay? The value of the definite integral will be the value of the function when the upper limit is substituted minus the value of the function, okay, when the lower limit is substituted. It's the difference. That's definite integral. As simple as that one, guys. There's no trick. In definite integral, there is a plus c and our final answer. Okay? Definite integral, there is no plus c. The reason why, we got a lower limit and we got an upper limit. Okay? So the value of the integral is actually specific, definite. That's why it's definite. There is an exact value. Okay? It's not indefinite. Okay? It will be f of a minus f of a. It's the difference. Okay? The problem here is the integration. So whatever integration you will encounter, okay, just integrate it. Just recall all the formulas under integration. Okay, I bring out two examples, two simple examples. Evaluate the definite integral, the integral with the limit 0 to 2 of the quantity 2x plus x squared minus x cubed plus quantity dx equal to. This is a definite integral. Why? It got the lower limit, it got the upper limit. Okay, let's do this. To visualize what we are doing, okay, I will give you a function of x plotted on the Cartesian coordinate system. This should be the y-axis, this is the x-axis, and this will be the graph y equal to a function of x. It seems the significance of this is that maybe the professor is asking the area of this, okay, the area under the curve when x equal to 0 and x is equal to a. Okay, try to visualize that as like that what we are doing. You see it, guys? The professor is asking what will be the area under the curve when x is equal to 0 and when x is equal to a. X equal to 0 and x equal to a are actually the boundaries. Okay? Boundaries. So it seems when you are evaluating definite integrals, these are two boundaries. The lower limit is the boundary on the left hand side, and 2 is actually the upper limit on the right hand side. Okay, try to visualize it as like this. Okay, let's proceed. Integrating this one, try to distribute. This should be 2, the integral from 0 to 2 of x dx, the first one, plus the integral from 0 to 2 of x squared. Sorry for this one, there should be a dx over here. Okay, dx. It's just the second one. The third one is minus. Minus the integral from 0 to 2 of x cubed dx. I just expand. Okay, then try to integrate. It's easy. It's just an illustration, so I give you an easy problem, like some other channels. Okay, so this will be 2 power formula. X is the integral of x dx, it falls under the power formula. U is x, du is dx, it is exact. So the integral will be x squared over 2. Second one, u is x, du is dx, it is exact. Power formula also. So it will be x cubed over 3. Third one, u is x, du is dx, it is exact. It is also power formula. So this will be x to the fourth over 4, close bracket, with the limit from 0 to 2. Okay, it is easy. Then try to substitute. Take this value 2, place it back here, minus, okay, the total value of this when the lower limit is substituted. So I got the minus sign over here. So this is actually, the first one is actually f of a, second one is minus f of b. As simple as that one, this is. Okay? Oh, it's just a matter of simplification. 2 squared is 4. This will be 8 thirds. This will be 16 over 4. This will be minus 4. 0 squared is 0. 0 cube is actually 0. 0 over 3 is 0. 0 to the fourth power is 0 divided by, sorry for this one, this will be 4. It is also 0. 0 plus 0 minus 0. So actually, the second part is actually all zeros. So this is gone. So what comes out is only this. So actually implicitly minus 0. This cancels. So the final answer will be 8 thirds. So it seems with the limit x equal to 0, x equal to 2, okay, the value is 8 thirds, meaning the area under the curve. It seems it's the area under the curve. This is x as a y as a function of x. Okay, it is this. Try to visualize it as like that so you'll get interest in the explanation, okay? When x equal to 0, x equal to 2, what will be the value of the area under the curve? It seems it's like that. Okay, try to visualize it as like that, okay? Okay, example number 2. Example number 2, evaluate the integral with the limit from 0 to pi over 2. This now involves trigonometric function, sine of 2x dx. Okay, to evaluate this one, you must have to integrate sine of 2x dx. There's a formula on how to take the integral of a sine function, right? But when we must have to verify the value of the angle. The value of the angle is 2x. du will be 2 dx. We don't have a 2 over there, so actually this is not exact. Okay? So to integrate this one, we introduce 1/2, the reciprocal of 2, the integral from 0, the limit from 0 to pi over 2, sine of 2x, the complete differential as per verification is 2 dx. And this is 1/2. The integral of sine function is negative cosine of that function, so it should be negative cosine of 2x with the limit from 0 to pi over 2. It should be negative. The integral of the sine is negative cosine. Okay, this should be, I bring out this negative sign, so this is now a common factor, negative 1/2, open bracket, cosine of 2 times pi over 2 minus cosine of 0. 2 and 2 cancels. Pi is actually equal to 180 degrees, right? It is this. Okay? And the second part is actually cosine of 0. 0 is actually the one on the right. They are actually opposite. They are both horizontal. This is 0 degree. This is pi, or 180 degrees. Rotated counterclockwise. Okay? So if we try to take the value, this should be negative 1/2, common factor, times the cosine of 180 is actually negative. It's pointing to the left, so it should be negative 1. And the cosine of 0, it's actually 1. So this is actually 1. Cosine of 0 is actually 1. So this is minus 1. Minus 1 is minus 2. So 2 cancels. Okay. So the value of the definite integral, okay, with the limit from 0 to pi over 2 of sine of 2x dx, the value is 1. Okay. And how do you graph this one? It is something like this. Okay. It could be, how do you figure out this one? Maybe it seems we are involving polar coordinates, okay? Maybe the problem is asking for the area, okay? The area under this curve, okay? With the limit from 0 to pi over 2. Okay? Oh, sorry for this one. Pi over 2 is 90 degrees. Pi over 2. This one. This is pi over 2. Maybe the problem is asking for the value under the curve, okay, with the limit from 0 to pi over 2. We are involving, it involves polar coordinates. It's not the Cartesian. Cartesian is x and y. Radius and angle is actually polar coordinates. So it seems the problem is asking for the area under the curve, okay, with the limit from 0 to pi over 2. Maybe the graph of this is the given equation of this. Okay? Try to visualize it as like that, so you'll get interest on why the lower limit and upper limit is given. Okay? So it seems the problem is asking for the area, okay, under this polar trigonometric equation with the limit from 0 to pi over 2. Oh, as simple as that one, guys. Sorry for that one. That's definite integral. It's not so hard. You are just given an integral, okay? The name definite. Why? Because it got a lower limit and upper limit. So you eliminate the plus c on the final answer. No plus c. Okay? So the difference between definite and indefinite integral, under indefinite integral, there is a plus c. Okay? And under definite integral, there is a lower limit b and upper limit a. Upper limit, lower limit. This is for definite integral. This is for indefinite integral. Okay, that's it, guys. Okay, the next time around, I will discuss the application of definite integrals, maybe in the computation of areas under a curve. Okay, if the curve is something like this, what will be the area under the curve with the limit from x equal to this value till this value? That's actually integration. The figure is irregular, so actually it's hard to compute. You cannot just use the value like in the rectangle, in a rectangle, length and width. And if we try to compute for the area, it will just be simply the product of length and width. Because actually, later on, we will derive this formula. Why the area of a rectangle is just the product of the length and width. Okay? So actually, this formula emanates from integral calculus. So actually, integral calculus is the foundation of the computation of areas. The derived formulas actually emanates from integral calculus. Okay, guys. Good evening.